Hello everyone, good day. My name is Ruben Flores and welcome back to my YouTube channel. It's been a while since the last time I have posted my video here in my YouTube channel. So therefore, I will be uploading more videos next week and it will be discussed all about related rates problems. So the objectives of this video is that first, the learner should be able to solve related rates problem presented and illustrate the given word problems into a mathematical statements. But before we proceed on presenting some examples solving related rates problems, let us first define what is related rates. Related rates problems involves two or more quantities that may vary with time, and an equation that expresses some relationships between these equations. Often the formula for x and y as functions of t are not known. So the symbol here is read as derivative of y with respect to x. So if we solve or we deal solving related rates problems, we expect to find the rate of change in terms of time. For today's video, I will be presenting related rates problems involving ladder. Next week, I will be uploading two more videos about related rates problem involving balloon and a cylinder. So first example, a 50 feet ladder is placed against a large building. The base of the ladder is resting on an oil spill and it slips at the rate of 3 feet per minute. Find the rate of change of the height of the top of the ladder above the ground at the instant when the base of the ladder is 30 feet from the base of the building. This is the given word problem, and first step we should do in solving related rates problem is to illustrate the given word problems itself. So assume that this figure here is our building, and then this is the ladder and the base or the ground, and denotes that the ladder here measures 50 feet and the bottom or the base of the ladder slips at the rate of change of 3 feet per minute, and we denote that as the rate of change on terms of x with respect to time. And since we are asked to find the rate of change in terms of y with respect to time here, or the top or the rate of change of the top of the ladder. And we also know that the given distance from the base of the building to the base of the ladder is 30 feet, and we denote that as our variable x. And the height of the ladder from the top to the base of the building is we denote as y. Solving this, we should first solve for the value of y, and since it forms a right triangle, we are able to use the Pythagorean theorem, which is the x squared plus y squared is equal to h squared. You can use any variables you wanted to use, but in this case, we denote as the bottom as x and the height as y, and our hypotenuse, which is h rather, so we have 50. Just plug in those values into the Pythagorean theorem, so we came up with 30 squared plus y squared is equal to 50 squared, and apply additive inverse by adding negative 900 both sides, or 30 squared both sides, so we came up with y squared is equal to 2500 as the square root of 50 and minus 900 as the square root of 30. So we apply also multiplicative inverse to eliminate the square, and we came up with y is equal to the square root of 1600 as the difference of 2500 minus 900. To finally find the exact value of y, we have to find the square root of 1600, and it would be equal to 40. And since we have the value of our y, we are asked to find the rate of change in terms of y with respect to time. So the same formula, we have x squared plus y squared is equal to 2,500, our hypotenuse, and do differentiation. So we came up with 2x x prime plus 2y prime is equal to 0. Since 2,500 is constant, and any constant, and the derivative of any constant is equal to 0. So x prime and y prime is also equal or the same with the rate of change in terms of y with respect to time, and the rate of change in terms of x with respect to time, or dy over dt and dx over dt. So we came up with dy over dt is equal to negative 2x dx over dt all over 2y, since we are asked to find the value of the rate of change in terms of y with respect to time, or dy over dt. And just simplify, so we came up with um, derivative of y with respect to time all over x equal to negative x dx over dt all over y. Just plug in those given values we have for our y, and we have for our dx over dt and for our x itself. So we came up with dy or over dt is equal to negative 30 multiplied to 3 all over 40, and we came up with the rate of change in terms of y with respect to time is equal to negative 9 all over 4, or simply negative 2.25 feet per minute. The negative sign here denotes that the rate of change or the top of the ladder move downward. So another example, a 13-meter ladder is leaning against a vertical wall with its foot on the same horizontal plane as the base of the wall. If the lower end of the ladder is moving away from the wall horizontally at 4 meters per minute, how fast is the top of the ladder descending when the lower end is 5 meters from the wall? So this is the given. And again, just illustrate the given problems to have a better understanding, or to be effective in solving the related rates problem. So assume that this is the wool, the figure presented is assume that that is our wool, and then the ladder itself, which is measured 13-meter, and the bottom or the base of the wool, rather the base of the ladder is moving 4 meter per minute, and we are asked to find the rate of change of the top of the ladder. Assume that this the last figure shown is assume that that is the ground or the base of both wool and the base of the ladder, which is measured x and denotes x, which is measured 5 meter, and the height we denote that as our y, and x, which is the distance from the wall to the foot of the ladder, and dx over dt, or the rate of change in terms of x with respect to time, is equal to x is increasing at 4 m per minute, and then in our y we have distance from the floor to the top of the ladder, and we have the dy over dt time a rate of change that we are looking for. Since it forms Pythagorean theorem, just use the same formula. But in this case, we are already finding the differentiations of the given Pythagorean theorem, which is x squared plus 2y is equal to 169, 2x dxr over dt plus 2y 2y dy all over dt is equal to 0, dy all over dt is equal to negative x dx all over dt all over y. It's the same process that we apply from the first example presented. If our x is 5, and from the given Pythagorean theorem, x squared plus y squared is equal to 169, so the value of y, if we do the same process from the first example, so we have the value of y, which is 12, and plug in those values to the formula of dy all over dt, which is equal to x dx all over dt all over y, for us to find the value of the rate of change in terms of y with respect to time. I am sorry, it would be t here, since it is with respect to time. And the next process is just plug in. So we have 4 and negative 4 quantity of 4 multiplied to quantity of 5 all over 12, and that would be equal to dy all over dt is equal to negative 5 all over 3 meter per minute, as the rate of change, um, the um, the the sub negative sign here denotes that the rate of change in terms of y with respect to time moving downward. The top of the ladder is down, descending or moving downward at the rate of 5 all over 3 meter per minute. And that will be all for today's video, and just keep on updating in my next video. Bye bye. Thank you.